Hi, welcome to Lesson 8.5, Solving Acute Triangle Problems. When we try to solve triangles, we need to find all the unknown sides and all the angle measures. So that's what is involved when we're trying to solve a triangle. So there's certain steps that you need to follow. First of all, if a description is given regarding a triangle and the diagram is not given, read the description very carefully and draw a diagram and clearly label it so that you can follow the different measurements of it and be able to visualize it so that that'll help you solve it. If they're right triangles, then use the three primary trigonometric ratios, sine, cosine, or tangent, depending on which angles you need and which sides you're given. If they're non-right triangles, then wherever possible use the sine law because it's a little bit easier. You're comparing two ratios. If it's not possible, then use the cosine law. The sine law, of course, is more efficient, but there are some times when you cannot use it. Sine law is used when a side and an opposite angle are given. That would produce a complete ratio for you to use to compare to another ratio where one of the either side or angle is not given. And the cosine is used when you're given all three sides or two sides and the contained angle. Okay, so let's take a look at this first example here. We want to solve for angle A. Take a look at this triangle. We want to solve for this measure of angle A here. We don't have any other angles given, but we do have all three sides. And by the looks of the angle, it does not look like it's a right triangle, so we cannot use any of the three primary trigonometric ratios. We don't have any angles, so using the sine law would be impossible because we can't form a ratio of any of the sides and angles. So because of that, that means that that rules out the sine law, which means we need to use the cosine law. And if we're trying to find the measure of angle A, that means we have to use the form of the cosine law that would solve for angle A. So across from the vertex A is side A, across from vertex B is side B, and across from vertex C is side C, all with lowercase letters. So the cosine of A is B squared, that's A squared minus B squared minus C squared all over negative 2BC. So all we have to do now is just substitute in the values, square all the values where needed, and complete all the calculations on the right side, and then take the inverse cosine to solve for the angle. So could you pause the video now, please, and calculate that, and then check back to see if you have done it correctly. So I'll substitute in 6 for A, 5.3 for B, and 7.2 for C. I guess technically I should, because I'm substituting these in, I should probably put them in brackets, even though it's not completely necessary. So I've got 36 minus 28.09 minus 51.84. And that is over negative 76.32. And so work out the numerator. So I got 36 minus 28.09 minus 51.84. That gives us negative 43.93 over negative 76.32. The fact that they're both negative is a good sign because then when you divide them, you'll get a positive and I divide this, and I get 0.5756. So I take the inverse cosine on both sides, so therefore angle A is going to equal 54.86 degrees. Let's just round it to the nearest whole degree, so let's say it's approximately 55 degrees. Okay, let's move along to the next example. We've got a roof being built with a base of 12.8 meters. We've got rafters forming 48 degrees with the horizontal and 34 degrees with the horizontal. We want to find out how long each of the rafters are. This is like an end view of the roof. Again, we take a look at this. 48 plus 34 would be 82 degrees. So because these do not add up to 90, that means the angle A is not 90 degrees, therefore it's not a right triangle, so we cannot use any of the three primary trigonometric ratios. We can find angle A because we've already given two angles, so that means we can find the third angle, and once we get angle A, we realize that it is across from a known side, so we can of course then use the sine law for that. So angle A equals 180 degrees minus 48 minus 34 which gives us 98 degrees. Okay, so to find side C, we're going to put C over sine of C, which is 34 degrees, and then we'll have side A, which is 12.8, and put that over the sine of 98 degrees. Cross multiply, so we get side C equals 12.8 sine of 34 over sine of 98, and then we calculate that. So we get 12.8 times sine of 34 divided by the sine of 98, which is 7.22 or 23 meters, I guess. Okay, and judging by the space there, let's just say it's 7.2 meters. Now finding side B, similar process. Side B is across from angle B, so we've got B over sine of 48 degrees, and that's equal to the same complete ratio that we used before, so we've got 12.8 over the sine of 98, cross multiply, so we got B equals 12.8 sine of 48 over the sine of 98, and as I do the calculation, we get 9.61, which I just round to 9.6 meters. Moving right along, on one bank of a river is a 130 meter building. So I guess here's the water here coming towards us. Here's the building. I guess maybe we can draw this with a little bit of perspective. Okay, so as we're sort of in the river, looking at this, here's the building, 130 meters tall. From across the bank, Mark measures the angle of elevation to the top of the building being 42 degrees. We want to know then how wide excuse me, the river is. Looking at the triangle, we see there's a right triangle. Therefore, we can use a primary trigonometric ratio. So we've got the angle. We have the opposite side. We need the adjacent side. So if we think of SOHCAHTOA, we realize that sine being opposite of our hypotenuse, we don't need the hypotenuse, so we don't need to use the sine ratio. Cosine ratio is the adjacent over hypotenuse. Again, hypotenuse is not part of this equation here. So we will then use the tangent, which is opposite and adjacent. So the tangent of the angle being 42 degrees is the opposite over the adjacent. We multiply both sides by the adjacent and divide both sides by the tan of 42. So the adjacent, being the width of the river, is 132 divided by the tangent of 42 degrees. And we just do the calculation here. And so we get 144.4 meters. So the width of the river is 144.4. On to the next example.